Good morning. How you all doing today? Mrs. Prod is laughing at me right now as I record this. She loved my good morning cheer. Okay, so we are down to our final lessons. That's it. It's kind of scary. I know. I went quick. So today is all about parallel lines and transversals. So if you look at this nice little picture, it is called the Transcontinental Railroad. Okay, because it goes across the continent. Yeah, I know. There's going to be more over here, but don't worry about that. So you hear different words with trans in it, such as transcontinental, transportation, transfer. Well, that's going to help you understand the word transversal. So before we get into that, we're first going to look at parallel lines. So you guys know parallel lines already. It's not very complicated. You know, they are two lines that travel in the same direction and never touch. One thing I want to go over with you, though, is to show that two lines are parallel. They put these little, almost looks like little arrows on them. I'll show you on the other slide how to actually draw that. Okay, and the way you write parallel lines is like this. It looks like two L's or two little lines straight up and down. So this just says P is parallel to Q. If two lines are not parallel, then they're intersecting. Now, there is one special kind of intersecting line, and it's called perpendicular lines, and a perpendicular line intersects at a right angle. Now, to know that they intersect at a right angle, one of the four corners, they put the little square in there. It means that each and every one of these is a right angle. It's just that they only put it in for one because it makes life a little bit easier. The way that you show two lines are parallel or perpendicular is by an upside down T. So L is perpendicular to M here. So that leads us to the transversal. So these are two parallel lines. This is called the transversal. So we said trans goes across. So a transversal cuts across two parallel lines. And when you do, you get 8 different angles. And the way they name the 8 angles are 4 of them are the intersection of one parallel line with the transversal, and then the other 4 is the intersection of the other parallel line with the transversal. So it's always labeled like this: 1, 2, 3, 4, 5, 6, 7, 8. Pretty complicated, I know. Okay. So with that, we have a concept known as corresponding angles. So corresponding angles are angles that are in the same relative location. So 1 and 5 would be considered corresponding because where are 1 and 5? They are both above their parallel line and they're to the left of the transversal. They're in the corresponding spot. 2 and 6 are corresponding because they are above the parallel line and to the right of the transversal. 3 and 7 are corresponding because they're below the parallel line to the left of the transversal. And finally, 4 and 8 are corresponding because they're below the parallel line and to the right of the transversal. Now, there's something special about corresponding angles. All corresponding angles are congruent. So 1 and 5 are congruent, 3 and 7 are congruent, 4 and 8 are congruent, 2 and 6 are congruent. Okay. Now, that also leads us to vertical angles. This is just a little review from earlier in the year. So vertical angles are angles that are across from each other when two lines intersect. So 1 and 4 are vertical angles. And also, if you remember, vertical angles are also congruent. So whatever 1 is, 4 is going to be the same measure. 2 and 3 are vertical, 5 and 8 are vertical, and finally 6 and 7 are vertical. So that leads us to what in the world do corresponding angles look like? One of the things that they'll do when you have equal angles or congruent angles is they will make this little kind of like semicircle, half circle, to show that these two angles are congruent. Now we know that this angle is also congruent because these are vertical, and because this one and that one are corresponding, those are congruent. So these 4 angles are all congruent. To show that other angles are congruent, but they have a different measure, we use a similar sign, but we double it for the second angle. Okay, so these 2 are congruent because they're vertical. Now this one and this one is congruent because they're corresponding. And then those 2 are congruent. So now let's use that to put into practice to figure out some of the angles here. Okay, so we need to find angle 1 and 2. So we know that this angle right there is 110. Well, what is the relationship of 1 to 110? They would be corresponding. And we know corresponding angles are always congruent. So angle 1 equals 110 degrees. Well, what do we know about angle 2? Well, angle 1 plus angle 2 form a straight angle. And we know a straight angle is equal to 180 degrees. And we also know that when two angles add up to 180, we call them supplementary. So we know that angle 2 plus 110 has to be 180. So we remove 110 from both sides. Angle 2 is 70 degrees. Helps if I write a 2 in that, doesn't it? All right. Again, same thing here. Our parallel lines are here. Again, you can see the little mark there. When you're drawing them, let me go back here. All you have to do is just do a little symbol like that. That will suffice for parallel lines. If there was a second set of parallel lines, there'd be another set in there. Okay, so here are parallel lines, L and M. The transversal is T. So we need to find angle 1 and 2. Well, angle 1 is corresponding to 63, so that has to be 63 degrees. 1 and 2 are supplementary. That would be 120, 117. 117 degrees. Okay? It's really not that awful, is it? Oh, can we find all 7 of these angles? Yes, you can. So now, can we figure out all these angles? Yes. Do you have to find them out in order? Absolutely not. You figure them out by what you know. So we know that 75 degrees is this angle. Well, we know there are corresponding angles to this. One of the corresponding angles to that, well, the only corresponding angle to that is angle 6. So since angle 6 is corresponding, we know 6 has to be 75 degrees. Well, if 6 is 75 degrees, I'll just write 75 in there, we know that 4 is vertical to 6. So 4 has to be 75 degrees. 1. So 1 has to be 75 degrees. And that takes care of all my 75 degrees. Now we can pick any one of these angles. We can pick 2, we can pick 3. Doesn't matter. We just know that. I'll just pick 2 right now, make my life easy. We know that 75 plus 2 has to equal 180. So angle 2 is 180 minus 75, or 105 degrees. Well, 2 and 3 are vertical of one another, so that happens to be 105 degrees. 5 is corresponding to 2, so that's 105 degrees. And 7 is vertical, so with 5, so that has to be 105 degrees. So the next thing we're going to look at is something called interior and exterior angles. Now, interior angles and exterior angles deal with their relation to the parallel lines. So here we have our 2 parallel lines, P and Q. Interior angles are the angles that are on the inside of the parallel line. So 3, 4, 5, and 6, they're both on the inside of the parallel line. They are called interior angles. 1, 2, 7, and 8 are called exterior angles because they're on the outside of the parallel line. So inside the parallel lines, you're interior. Outside the parallel lines, you're exterior. So that's going to lead us to the other 2 types of angles that we're going to look at today, which are called alternate interior angles. Okay, a lot of words, very simple. Interior, we already covered, means inside the parallel lines. Okay. Alternate, well, think about it. What's an alternate? The alternate means you go back and forth. Okay, so alternate is opposite sides of the transversal, on alternate sides of the transversal. So interior is parallel lines, alternate is transversal. Okay. So this line is on the this angle is on the inside of the parallel line. The angle that's going to be an alternate interior with that is going to be on the other side of the transversal, on the other parallel line. So it's this angle with the top parallel line, this angle with the bottom parallel line, and they're on opposite sides of the transversal. The other set of alternate interiors is this angle, 2 lines in a different color, And it would be this one because they're both on the inside of the parallel line. This is with the top parallel line. This is with the bottom parallel line. And they're on the opposite sides of the transversal. Now, one of the things about alternate interior angles is they are congruent. Okay, so this angle is congruent to that angle. That angle is congruent to that angle. Exterior, and that's what we are going to deal with. So exterior deals with on the outside of the parallel lines. Alternate means the opposite side of the transversal. So this angle is on the outside of this parallel line on this side of the transversal. Its match will be on the bottom side of the other parallel line to the right of the transversal. So this angle, and this angle are called alternate exterior angles. Alternate, opposite sides of the transversal, exterior on the outside of the parallel lines. Is this angle, this one, and this one. Those are alternate exteriors. They're on the outside of the parallel lines, opposite sides of the transversal. Now, what happens with alternate exterior angles? Yep, they are congruent. So this angle and that angle are congruent. That angle and that angle are congruent. So that leads us to this one. So we're going to use what we just did to figure out the answer to this question. So the stairs have an incline of 45 degrees. At what angle do you need to attach your rail to two parallel posts so that the rail is parallel to the incline of the steps? Okay, so they want us to find this angle and that angle, 6 and 4. Okay. Angle 4 and angle 6. So we're going to have to use what we learned to try to figure out the degrees. So the one angle they give us is right here. This is a 45-degree angle. And it's telling us that this line and this line are perpendicular. So we know that they are equal 90 degrees. Okay? So this angle is 90 degrees, plus it tells us that. So 1 and 45 have to add up to 90 degrees. Well, if that's 45, angle 1 has to be 45. Okay, that's great. How does it help us with 6? Because these are parallel. But these are also parallel. You see how we have the little mark there, and then 2 of them here? That's just showing how they're different. So, can't go directly between, well, if you know a little bit about parallelograms, you know that opposite angles are congruent, so 6 is going to be 45. But we're going to prove it a different way. If you look, this is a parallel line cut by a transversal. So 1 is an interior angle. Well, we know that the alternate interior to 1 is also going to be the same measure, or 45. So angle 2 is going to be 45. Well, 6 and 2 just happen to be corresponding because, again, these two are these two we're looking at are parallel. There's your transversal, so 6 and 2 are corresponding, so 6 has to be 45. Well, looking at this, you notice they extended these lines up, okay? So 6 is alternate interior with 5, so that means 5 has to be 45. Oops, 5 equals 45. Well, 45 plus what gives you 180? That would be 135 degrees. So 4 would be 135. So if you make this angle 45 and this angle 135, you will have parallel lines. Thank you, guys. Have a good day. Reach out if you need any help. Bye.